Hello everyone. Today we are going to be looking at integration by substitutions. The things we will cover in this section is you're going to use a change of variables to find an indefinite integral, use change of variables to evaluate a definite integral, and then we will also evaluate a definite integral which involves even or odd functions. The first thing to keep in mind is that when we're doing a change of variable techniques, what kind of problems are we encountering in this integrals? These problems which we encounter are functions which are composite functions. And so if you notice over here, the composite functions f of g of x. So these kind of problems are the problems we will be working in this section. This change of variable technique or the u-substitution, which we are looking at in this section, it is comparable to the chain rule in differentials. So when we change these variables, so what we are basically doing is we are rewriting the integrals in terms of u and du. And that takes us to a familiar kind of integral techniques we have learned, like integral of x to the power n dx and kind of things. So it makes our life more simpler. And this change of variable technique uses the Leibniz notation for the differential. That is, if u is g of x, then d of u is g prime of x dx. And this is the integral which takes. So it's f composed with g of x, that is f of g of x, times g prime of x dx. So when we have composite functions, this looks like a very simple kind of integral when you change the variables or u substitution into f of u du. So when you take the integral, it is the capital F of u plus a constant. This capital F of u is the antiderivative. So we can think of the integration of u substitution by u substitution as undoing differentiation using the chain rule. Now, before we go into the examples, I'd just like to have a little steps on which we will do these u substitutions. First of all, I would like to identify what is my u. Remember, u was, so if you have a composite function, f of g of x, you are saying, so this composite function, you're saying, let u be equal to g of x. So if you remember from your differential times that this g of x is the inside function. So we're trying to look for the inside function. And once you have figured the correct u, then you find the differential of u and rewrite the whole integral in terms of u. For example, so when we had this example of f of g of x and times g prime of x dx. So when we say let u be g of x, so which is the inside function, then when we take d of u here, what do we get? G prime of x dx. Okay, and then you do the substitution over here, which is equal to f of u. Remember, g of x is u, and g prime of x dx is d of u. And then we do the normal integrals, and then the final answer we get, we have to go back to the original variable. Remember, the original variable is x. And if you want to make sure that we're doing correct, the best hint is you check your results by differentiating. Okay, now let's start with examples. Now, the first example is we are given a function 4x plus 5 to the power 9 times 4 dx. Now, just a simple recollection that we are very familiar if we have problems of the kind x to the power n dx. You know the power rule for integrals. This was x to the power n plus 1 over n plus 1 plus c. Now, how we do make this? Oh, I have to do the u substitution. The best way to look at it is when you're given a problem and you have something raised to power something, But the inside term, which is raised to having some powers in it, if this function, inside function, has more than one term, the first thing you should think, oh, I might need to use u substitution. That's the first way to start the problem. So I'm saying something to the power something, and the one which is being raised, the base which is being raised to a power has more than one term. So I say that might be my u. Okay, let's see if it works. If u, here I'm saying is 4x plus 5. Okay. So once we have got this u, that's one way of looking at it. Another way of looking at it is, if this is my function f of g of x, if you're more comfortable with the inside-outside function, you say, oh, this is the inside function raised to the power 9. So that also is another way of looking at the problem. There are many ways, so I'm just giving you two over here. Whichever makes you comfortable, use that. So once we have figured out what is the right u, then we just do the next step. The next step is find du of u, which is basically differential of this on the right-hand side times dx. So once we have got our u substitution, we go back to the original problem. And everything we have, we're going to replace by x's. Every x has to be replaced in terms of u's here. So when you replace it, so let's look at this one. So now, 4x plus 5 to the power 9, 4 dx. Notice 4x plus 5 is what? U. So we write this as u to the power 9. Notice 4 dx is du. So du, this 4 dx is going to be du. And 4x plus 5 to the is the u substitution. And after that is a simple power rule. So what you get here is u to the power 10 over 10. Remember, you put the c at the very end, the final. Now you have done your integrals. And after that, just replace the u by 4x plus 5 because the original problem was in x. So it's 4x plus 5 to the power 10 over 10, and then the final answer it is, put a c. Okay. Now in the next problem, what do we notice? We have 3x minus 2 to the power 5. So remember, this function, I have to figure out it is a composite function. The inside function is 3x minus 2. The outside function is a 5. So the idea is make the inside function to be u. So here we're going to say u equals 3x minus 2. Okay, the next step, d of u. d of u is what? 3 dx. Then we go to the original problem. We say, oh, I have a dx, but I don't have a 3. So replace your dx, take the 3 out of it and say du over 3 is dx. Now everything which is inside the original integral can be changed in terms of the u's here. Okay, so this example is now going to be 3x minus 2 is going to be u, 5. Dx is now du over 3. du over 3. Now we know how to solve this one. This is the same thing as saying integral 1/3 u to the power 5 du. Now remember, it's a constant multiplied to a function. You take the constant outside, and then you have u to the power 5 du. Now we all know how to solve this u to the power 5, which is 1/3 times u to the power 6 over 6. Then u to the power 6 over 18. Remember, you have to change the u into an x in the form of where it all started. This was the substitution, guys. So your final answer is 3x minus 2 to the power 6 over 18 plus, remember this is an indefinite integral, you put a c there. Okay, so We're going to do a little bit more practice of these kind of problems so that we get comfortable with it. Now let's look at the next set of problems. Once again, when I look at the first integral, I have 1 plus 2x to the power 7. Now clearly it is not the normal x to the power n, because here I have an expression with the base has more than one term. Oh, that means there's a u substitution. So we're going to say this is the inside function, and when it is raised to the power 7, the one which is raising to the 7 outside function. So my u here is going to be 1 plus 2x. Then the next step, find du, which is 2 dx. So when I'm making my changes, I don't have a 2, so I only have a dx. So what I'm going to do, I write du over 2 equals dx. So what does this look like now? This is integral u to the power 7 times du over 2. Now remember, your half is a constant, pull that out, and you have u to the power 7 du. And then what we're going to do? Now it's going to be half u to the power, apply the integral, over 8. Your final answer is not final, almost there, u to the power 8 over 16. And remember, the final answer will be replacing the u by that substitution we did, which is now going to be 1 plus 2x to the power 8 over 16 plus c. Okay, now let's look at this integral. 3x squared minus 5 to the power 7, 6x dx. So, I have to make the decision, is which one is the composite function. Composite functions, guys, remember, is the, and it's like the inside-outside functions. So here, my inside function is the squaring function, 3x squared minus 5, and this whole expression is raised to the power 7. As this function is raised to the power 7, the inside function, remember, has more than one term. So automatically we're going to say, oh, this is going to be my u. Great. So we're going to say, let u be equal to 3x squared minus 5. What is my du? Du is 6x dx. Wow, this 6x dx is already there. Easy work for us. Okay, so now what this expression is now going to look like? This expression is integral u to the power 7. 6x dx is what? Du. So when you apply the integral rules, it's u to the power 8 over 8. Remember, final answer has to be in terms of the variable, original variable. And this was the substitution. U was 3x squared minus 5 to the power 8 over 8. Remember, it's an indefinite integrals. You put a c. Okay. Now we're going to increase the intensity of these composite functions. Now in our expressions, we're not having that nice little polynomials. We're having radical roots. Oh, how will we do those? Once again, when I look at this expression, it's a quadratic function raised to the power half. So it's like there's the base raised to power something. So automatically, oh, the inside function is the quadratic function we have. Remember, 1 minus x squared is the same. Square root of this is writing as 1 minus 6x squared to the power half. So the inside function is 1 minus 6x squared. Every time say, which is the inside function? It makes life more simpler. Okay, so we're going to say, hey, u is going to be 1 minus 6x squared. Okay, the next step in the u substitution, find du. Minus 12x dx. So every time you're doing this, you go back to the original problem and say, oh, what is missing, what is present? So what I see is the presence of minus x dx. The 12 is not there, so we can remove this and write the original, that du as du over 12 equals minus x dx. Now this minus x dx, guys, is the same as this. Now we are almost ready for making all the changes. The x variables of the integrands are going to be now written in terms of the u's. Okay, so this whole expression down is now going to be written as this whole integral is square root u du over 12. Make it much more nicer looking, and taking the 1 over 12 outside, u to the power half du. Now this is simple, integral rules. U to the power 3 half over 3 half, and then you take the 3 halves up, which is going to be what? 112 times 2 3s, u 3 halves. So what your answer is 1 over 18, because 2 times 6, so 1 over 18 u. We're going to replace the u by 1 minus 6x squared, 3 halves, plus a c. Okay, we have done this one. In a similar fashion, we have another problem, but here instead of having a square root, we have a fourth root of a cubic function, 5x cubed minus 7 times x squared. Okay, so in this one, once again, the inside function is a cubic function, which is raised to the power 1/4. So notice this one is actually 5x cubed minus 7 to the power 1/4. Okay, so the inside function is a cubic function, as I said. So we're going to go ahead and make the substitution. U equals 5x cubed minus 7. Next step, find du, which is 15x squared dx. So then every time you do something, go back to the original problem. What am I going to be needing and what I'm not needing? So already I have x squared dx. So that means I need to write my x squared dx as du over 15 equals x squared dx. Okay, now just make all the replacements in the original problem. So this is going to be integral u to the power 1/4 times du over 15. So you take 1 over 15 out, integral u to the power 1/4 du. So what are you going to get? 1/15 u to the power 5/4 over 5/4, which is basically 4 over 75. Replace the u by 5x cubed minus 7 to the power 5/4. And as usual, in the end, we write, okay, it just looks like a 9 to me, plus c. Remember the plus c thing, guys. Okay, just a little bit more practice of problems. Okay, now we're going to do an integral, a cubic function raised to the power 7 times x squared dx. Okay, once again, my u is the inside function, 3x cubed minus 5. What's my du? Du is 9x squared. Now remember, and dx, so we have x squared dx, so it's du over 9. So when we do the math here, guys, now the integral is now equal to u to the power 7 times du over 9. Take the 1 9 and u to the power 7 du. You get 1 over 9 u to the power 8 over 8. Replace the u by 3x cubed minus 5 to the power 8. 9 times 8, 72, and the final answer, a C. Okay, let's look at this one. The second problem. integral of x cubed minus 2x4 minus 5 to the power 8. So here, the inside function, remember x cubed is on its own, but then the next expression is the one which gives us the, oh, this is my u. So here my u is minus 2x4 minus 5, and my du is minus 8x cubed dx. And after that, guys, we just are going to do the u substitution to the original problem. Now this is x cubed. Now remember, x cubed dx, oops, sorry. Okay, the x cubed dx, guys, is like the du over minus 8 for us. Okay, so I forgot to do that here. So du over minus 8 equals x cubed dx. So when I make the changes, so I'm going to have u to the power 8 times du over negative 8. Now this is very simple solving. What are we going to get? You're going to get minus 1 over 8 u to the power 9 over 9. Final answer, minus in the front, minus 2x to the 4 minus 5 to the power 9 divided by 72 again, and plus c in the end. Okay, 2 more examples to get ourselves into the familiarity of doing the u substitutions. So here we're going to evaluate this integral x square root x squared minus 3. So this one, clearly something in the inside and outside. So I hope you started to recognize a pattern, what kind of inside and outside functions I have to look. So not this x, but this expression gives me the leeway. Oh, x squared minus 3 is going to be my u. So we say u equals x squared minus 3, and du is 2x dx. Now remember, we have an x and a dx, but we need 2. So that means we can simply write du over 2x dx. So this now problem is going to be written as x dx is going to be now du over 2, and the other part is u to the power half du over 2. So half out, it is u 3 halves over 3 halves, and then, so this 2 and a 2 cancel out. So we have 1/3, replace the u by x squared minus 3, raised to the power 3 halves plus c. Okay, the next problem, you have integral of x cubed and the cube root of 4x4 plus 9. So clearly, this is the composite function that has an inside and outside. And this one is an expression of a radical root, 4x4 plus 9, change it to an exponential form, 1/3. So clearly, the inside function is a fourth degree polynomial, sorry. So we say this is my u. U is 4x4 plus 9. So my du is 16x cubed dx. Du over 16 is x cubed dx. The reason is we have x cubed and dx. We don't have a 16, so we can take that out. So now the original problem in terms of u is going to be u to the power 1/3 du over 16, which is 1 over 16 u 1/3 du. Now you can easily do the math here. 1/16 times u, which is 4/3, u to the power 4/3 over 4/3. And the final answer is going to be 3 over 64. Okay, u will be replaced by 4x4 plus 9 to the power 4/3. Okay, I need a little bit more space, so I'm just going to remove this one. So final answer, guys. So it's 3/64, 4x4 plus 9 to the power 4/3 plus c. Okay, so we have done a lot of practice problems today. And I would like you guys to practice some of them. Okay, let me see something here. I just wanted to make sure, yeah, that's right. Okay. Some plus minuses. Want to make just sure some, if I make, yeah. Okay, so here's it. Now I would like you to practice these problems, guys. And they're very important before we start a little bit more difficult kind of problems in u-substitution. Okay, so before we start, I would recommend you guys to practice the problems in slide number 10 and slide number 11. When you practice these problems, you're going to be more comfortable, and then we will start with the next level of difficulty of our problems.